Good day everyone, I am Mitch Angelo Lazaro Benting from TEP 48 and today I am going to discuss the unit circle. So here we have 0 degrees and a full circle is 2 pi. Half a circle is 1 pi and half of pi is pi over 2. So you can think of this as 1 pi over 2. Pi is the same as 2 pi over 2 and this is 3 pi over 2. And 4 pi over 2 is the same as 2 pi, which will take us back to 0. Now what we're gonna do at this point is break up the unit circle into 8 equal parts. Now the first one is going to be 1 pi over 4. 2 pi over 4 reduces to pi over 2. And here we're gonna have 3 pi over 4. And then 4 pi over 4 simplifies to pi. This is 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2. And this is 7 pi over 4. And 8 pi over 4 is the same as 2 pi. Now the next thing we're going to look is this angle, which is pi over 6. And then 2 pi over 6 reduces to pi over 3. 3 pi over 6 is the same as pi over 2. Next, we have 4 pi over 6, which reduces to 2 pi over 3. And then over here, 5 pi over 6, we can't reduce that to anything, so we're going to write that. 6 pi over 6 is pi. Next, we have 7 pi over 6, and then 8 pi over 6 reduces to 4 pi over 3. We'll have to put that over here. 9 pi over 6 is 3 pi over 2. And then 10 pi over 6, if you divide 10 and 6 by 2, you get 5 pi over 3. And 11 pi over 6 can't be reduced, so we're going to write that here. And so that's how you can get the other angles in radians. Now we need to talk about the values that correspond to these angles. So let's focus on the values that are located on the x-axis and on the y-axis. So on the x-axis, to the right x is going to be 1. For the unit circle, the radius is 1. On the left side, x is negative 1. And the y-axis is always 0. X is 0 at the center. Now for the y values, y is 0 on the x-axis. At the top, y is positive 1. At the bottom, y is negative 1. Now let's focus on quadrant 1. Quadrant 1 is located on the upper right corner. Quadrant 2 is located on the upper left corner. Quadrant 3 is located at the bottom left. And quadrant 4 is located in the lower right corner. In quadrant 1, both x and y are positive. Now let's write the values that corresponds to pi over 3, pi over 4, and pi over 6. So let's go in this direction. First, let's focus on the x values. So we're going to increase it from 0 to 1. So this is going to be 1 over 2. Or you can think of it as square root 1 over 2. And then square root 2 over 2. Square root 3 over 2. And this is equivalent to square root 4 over 2, which is 1. Now, for the y values, we're going to increase from 0 to 1 in this direction. So after the 0, it's going to be square root 1 over 2, and then square root 2 over 2, and finally square root 3 over 2. And square root 4 over 2 is 1. That's the quick and single way to find out what these values are on the right side. Now to find the other values, it's going to be a reflection of what you see here across the y-axis. The only thing that will change is the signs. In quadrant 1, we said that both x and y are positive. In quadrant 2, x is negative and y is positive. X is negative on the left side. Y is negative below the x-axis. So let's go ahead and fill in the values for quadrant 2. So you notice that we see here square root 3 over 2 and 1 over 2. You went to copy that on the left side. So this gonna be the same thing on this side. However, the x value will be negative. That's the only difference. So exactly what we see at pi before, we're gonna copy that for 3 pi over 4, just making the x value negative. And what we see here for pi over 3, we're going to copy it for 2 pi over 3, but it's going to be negative 1/2 or 1 over 2. Now in quadrant 3, both x and y are negative. So all of the values with pi over 6, like pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6, they will all have the same value, square root 3 over 2, comma, 1 over 2. But the sign will vary based on the quadrant it's located in. So 7 pi over 6 will have the same values as pi over 6. However, both x and y will be negative. 5 pi over 4 will have the same values as pi over 4, but x and y are both negative in quadrant 3. And 4 pi over 3 is going to be similar to pi over 3, but everything is going to be negative. In quadrant 4, x is positive on the right side, but y is negative below the x-axis. 11 pi over 6 is going to be similar to pi over 6, but only y is negative this time. 7 pi over 4 will be similar to pi over 4, and 5 pi over 3 is going to be similar to pi over 3, but y is negative. Now you see, you need to know the angles in degrees, and you could simply convert the angles from its radian value to its degree value. And just know this pi is equal to 180 degrees. So to convert an angle measure from radians to degrees, just replace pi with 180. So here we have pi over 6. 180 divided by 6 is 30. Here we have pi over 4. So 180 divided by 4, that's 45. And this is pi over 3. 180 divided by 3 is 60. This is pi over 2. 180 divided by 2 is 90. 2 pi over 3 is 180 divided by 3 is 60 times 2, that's 120. 3 pi over 4, 180 divided by 4 is 45 times 3, that's 135. 5 pi over 6, 180 over 6 is 30 times 5, you get 150. And then pi is 180. 7 pi over 6. Pi over 6 times 7, so that's 30 times 7, you get 210. 5 pi over 4, 180 divided by 4 is 45 times 5 is 225. 4 pi over 3, 4 times this value, pi over 3, 4 times 60 is 240. 3 pi over 4 is 3 times pi over 2, or 3 times 90, so that's 270. 5 pi over 3, it's 5 times pi over 3, which is 5 times 60, so that's 300. 7 pi over 4 is 7 times 45 is 315. And 11 pi over 6 is 11 times 30, so that is 330. And so that's how you can quickly populate the angle measure in degrees and the unit circle. This image shows a right angled triangle ABC where angle theta is the angle of interest. Side A is the opposite to angle theta. Side B is the side adjacent to angle theta. Side C is the hypotenuse, or the longest side opposite the right angle. The 6 trigonometric functions. Sine. The sine of an angle theta is the ratio of the length of the side opposite the angle to the length of the hypotenuse. In the image, this is presented as sine theta equals A over C. Cosine. The cosine of an angle theta is the ratio of the length of the side adjacent to the angle to the length of the hypotenuse. This is presented as cos theta equals B over C. Tangent. The tangent of an angle theta is the ratio of the length of the side opposite the angle to the length of the side adjacent to the angle. This is presented as tan theta equals A over B. Cosecant. The cosecant is the reciprocal of the sine function. Therefore, CSC theta is equals 1 over sine theta equals C over A. Secant. The secant is the reciprocal of the cosine function. Therefore, sec theta equals 1 over cos theta equals C over B. And last is cotangent. The cotangent is the reciprocal of the tangent function. Therefore, cot theta is equals 1 over tan theta equals B over A. This image clearly defines the 6 trigonometric functions and the reciprocal relationships within a right-angled triangle. Right-angled triangle. These trigonometric functions are defined specifically for right-angled triangles, triangles with 190 degrees angle.